Hello and welcome to Instant Insights, a global data strategic intelligence. We track over 100 tech, industry, ESG, and macro themes impacting all major sectors. I'm your host today, Martina Raveni, and today I'm joined by Adrian Barker, the Key Account Director at EkkoSense, a data center optimization software provider. Hi, Adrian. Welcome back to Instant Insights. How are you?
Very well, Martina. Nice to talk to you again.
Thank you. We met in March at the Data Center World Conference, which took place in London. And I saw you at the stand. It seems we're doing really well. How did you find the conference?
DCW 2026 was a great event for EkkoSense, both in terms of all the people who took the time to come to our stand, as well as providing us with a great platform to introduce a couple of new tools. So we have our new automated cooling anomaly detection capability, which is going to be more and more important for the advancement of hybrid cooling systems, as well as previewing our advanced Echo Chill capability that's going to provide critical insights into the chilled water performance efficiency of a whole data center site. We also had the opportunity to present alongside our customer Bulk and discuss some of the challenges faced in the deployment of these new large-scale, high-density AI factories. So DCW 2026 was a really important show for EkkoSense.
Yeah, and there were, as you said, a lot of people and really showing how the industry is quite interesting in data center, and it's a hot topic at the moment. And I remember that when we met, we had the opportunity to discuss, as you mentioned, the latest developments of your company. That's exactly what I would like to talk about today. First things first, let's start. Data centers are facing a cooling challenge. We know that we have data centers scaling up rapidly to meet an accelerating and increasing artificial intelligence demand. And connected to this, there is a huge requirement for data center cooling solutions that can keep pace with the many high density artificial intelligence racks. And many of our listeners might be aware of the topic already, I'm sure, but for the ones who are not, could you give us an introduction about why data centers cooling is important and is even more important in the recent years, and how the industry is managing this complex issue?
Sure. It's the whole data center cooling has evolved really into a much more complex challenge than it's ever been before. With the rise of AI, which is primarily driven or driving GPU type architectures, rack densities have gone up enormously, and we're now looking at typical rack densities in excess of 100 kilowatts per rack. And if you don't look too far forward, we're starting to scale that to over 500 kilowatts per rack. And if you look at the way NVIDIA are developing their GPUs, it tends to be the pathway that everybody's on. There's a rapid growth in that space as well. This then leads to the value of these IT assets being in excess of multi-millions per rack. So you're cooling very, very expensive equipment, and you don't want to get to a point where you undercool and that equipment fails because it's millions of dollars at a time as opposed to hundreds of thousands, which it used to be. Um, Air cooling is now a limitation within the data center. We have to have liquid cooling. Typically, we're seeing a lot of CDU-led liquid cooling. I know there's other solutions such as rear door and immersion bath, but both of those don't really hit the power densities that the CDU-assisted racks can. And this total necessity for liquid cooling is now very much at the forefront of modern data center design. But it's always going to be a hybrid architecture. You can only liquid cool part of the rack, and there are some parts of the IT assets that still need air cooling. So I think the most important part is considering how you manage a hybrid cooling environment, which is predominantly liquid cooled, but there's also quite a significant part that's still traditionally air cooled.
Okay, and I guess that it's quite up to the aim or goal or type of work of the company having a major amount of liquid cooling or air cooling like this.
Yeah, I think it depends on where you're coming from and what you're doing. So if it's a brand new architecture that's going to be AI factory, GPU centric, Then you start off with all your racks being CDU cooled, and you add the air cooling in to support that. You will have examples where clients are moving part of their data hall across to liquid cooling and taking a step in that direction rather than a wholesale movement. And then you've very much got a blended environment where, for example, we have clients that are running 8 megawatt data halls, typically air cooled, and now they're putting in 2.4 megawatt pods of liquid cooling. That's consuming half of or a quarter of the hall in a very, very small space. So density is going up, and the complexity of managing liquid and air cooling is becoming even more complex for the data center operator.
Yeah, makes sense. No, thanks, Adrian. That's a great introduction to set the scene. We've been covering the in global data the cooling system, and we know from estimates that cooling and air conditioning systems within data center are major energy consumers. They account for around 40% of data centers energy demand, and energy demand is another, it's connected to it, but it's one of the other big issue, big challenge of this theme. And data center operation, you will know better than me, in your company are busy considering how their plans to accommodate the higher energy AI racks will impact their cooling solution strategy going forward, because they need to take in consideration how to proceed. So, from your experience, which key questions do they need to be asking? Like, what do they need to think about when setting up a data center?
I think there's a lot of questions at this point. It's not just a handful. Some of the key ones that spring to mind are: what is the optimal balance in that hybrid system between air cooling and liquid cooling? How do you mix that across your rooms? And how do you actually plan to synchronize that and make sure that that's running optimally as the IT load is deployed and then ramps and is running at maximum capacity? What temperature can your new AI compute engine safely operate at? We've got scenarios now where we are using chilled water via CDUs off the current loops, but we're talking about next generation compute, which will actually have warm water cooling systems. So not only do you have a hybrid cooling system, you potentially have two different water temperatures running through that data center as well. So those design decisions need to be made up front to minimize the complexity of those systems. Obviously, when you introduce liquid cooling into the data center, you've got leaks and the risk of leaks. So data center operators have to plan for that, understand how they're going to manage leaks, because they are going to happen at some point, and then how they pick that up and then manage those potential leaks to minimize any impact to compute performance and risk to the racks. You've got dynamic IT loads. So how do you actually manage your cooling systems to be as efficient as possible while you've got change in heat flux within the space? So real-time monitoring is going to be really important to understand where that's going. And in certain cases, predictive monitoring. So understanding where the load is going to go so you can pre-cool the space. It's probably a little bit more advanced for the moment, but it's certainly where developments are going. In terms of your CDUs, are they delivering a thermally uniform performance? Are they actually meeting the requirements that the racks are demanding? So we don't want those CDUs to lag the IT performance. We have to have those on point and delivering the right cooling to manage the loads and make sure that those workloads maximize. The hardware is very, very expensive, so getting the maximum work out of it is going to be important for these providers. In terms of data monitoring and liquid cooling flows, where are you going to monitor those points? What are the key points within your data center you need to monitor? What's the granularity you need to monitor at? And what actually are you looking to measure? Is it just flow rates? Is it temperatures? You're going to need both of those, but then you need to start considering things like contamination within the liquid as well. So there's lots of new reasons why the liquid cooling is going to lose performance going forward. You need to make sure you're measuring and monitoring all of that. In terms of your whole chilled water system that's then supporting your liquid cooling, have you got visibility holistically across the performance of that from an end-to-end point? Because you've got now white space and grey space that you need to look at the same time and holistically understand how your chiller performance is affecting the white space and how that CDU performance is moving forward. Um, do you have balanced chiller staging? What are your flow rates and temperatures to make sure that as your IT loads are fluctuating, you're able to support that, but make sure you're not then overcooling when the IT loads drop off as your workloads fall back. There's quite a change in the thermal output from these servers when they're under full workload or when they're in standby. There's a real sweet spot in terms of where data collection needs to come from for the chillers in these AI data centers. So you may need to make sure that you're monitoring at the right points there. And I think more crucially, who actually owns and controls all of that? You've typically got, I think, a three-layer stack within this AI factory where you've got the site, the hardware layer, and then the application layer. And each of those different levels is going to require a different layer of monitoring and who actually controls it. In some cases, you'll have the site managing the CDUs for the client. In other cases, the CDUs will be managed by the hardware client at that point. So there's going to be a lot of handoff and sharing of data, just making sure that all that's in the right place at the right time.
Fair. I mean, a lot of question, and I'm
Yeah,
sure there are many more. I won't ask you there. I would like to ask you many clarification on every question, but it would be a very long podcast. I have just one to follow up. Um, we are continuously talking about data centers are hot. We need to dissipate the amount of heat created by the AI workload, but which kind of temperature we are talking about?
yeah, okay, good question. So, in terms of the air that's delivered to that rack, it hasn't really changed. So, at the moment, we need to be delivering air within the ASHRAE guidelines, maybe up to a maximum of 27 degrees Celsius that hits the rack to cool the non-liquid cooled components. And then these chips, these GPUs are running very, very hot. So, we need to keep them at their optimum temperature, and the only way to do that is to use a liquid medium, which allows better heat transfer than air, which is why liquid cooling is in place there. So a data center won't necessarily feel a huge amount warmer. Certainly in the cold aisle side of that, the hot aisle, where all the exhaust air is coming out, temperatures are increasing there. And you've got the ongoing challenge of work time for human operatives within that space. That's something that data center operators are having to address as well. I guess that's just a natural byproduct of running IT hardware faster and with more power. But temperatures in as you walk into a data center, it's not like a hotspot with on the planet. There's just a lot more power being consumed, and obviously the necessary cooling to cool that down so that the chips operate as optimally as possible.
I see. I see. No, thanks so much. I was quite curious. And you told us all these kind of question, all these kind of points that we need to take in consideration when building data centers. So I wanted to ask you, how is the EkkoSense platform helping it this? So how it can be integrated? Which are the main benefits? So if you could tell me a bit about this.
Sure. It's really all about absolute operational visibility. So you're going to need to see how those high density AI deployments are operating from a thermal and power perspective in real time. So EchoSoft Critical ensures this. We enable data center teams to see everything and really miss nothing. And the data can come in via integration, directly from the CDUs or from our own sensors that we can put into the space. So as long as we're collecting the data, and then we're able to really make the invisible visible and allow our data center operators to have the operational intelligence and a layer of data that's particularly important for today's high density AI deployments. Running AI is a complex task. There's an absolute clear need for tighter tolerances and faster response times. You're running a lot hotter. And that's where our anomaly detection becomes more and more important because it's going to give data center operational teams an advanced warning of a potential failure within the data center. So it gives them more time to respond and manage those AI loads. And that really reinforces the requirement for best practice data center optimization via a partner such as EkkoSense. Obviously the EkkoSense critical tool is very easy to install.
Is the
Um,
one you showed me at the conference?
that's right. Yes. Yeah. Yeah.
Okay,
You saw the
I got
tool at
it.
the conference. So it shows you what's going on in real time, and will give you optimization tasks to enhance that data center operation in real time. Whether it's an edge, distributed IT, a legacy site, co-location provider, or today's AI factory and hyperscale facilities, the software gets you straight to the data that you need to run the sites more efficiently. If I think about some specific ways that EkkoSense can help with that, is the removal of thermal and power risks. With the anomaly detection I mentioned earlier, it's going to give you early warnings before critical equipment gets into a failure mode. This is often data that's hidden from the BMS because we're looking at multiple data points and how that's trending over time. Reducing cooling energy costs. Our real-time cooling advisor analytics support hybrid and air-cooled systems now, and that's going to help you optimize and reduce your cooling costs as time goes on. The ability to release critical power and cooling capacity, so we can find stranded power and capacity within the data center. These sites are so expensive to build nowadays that being able to maximize your operational capacity is really important. And obviously, we start talking about ESG as well. Data centers are in the news a lot. Everybody talks about them being high energy consumers. So anything that we can do to help reduce the carbon footprint and solve the ESG problems that these data centers have, and with the data that we capture and the analytics and insight that we provide, we can help clients reduce their carbon footprint and be ready to report against their ESG requirements against the ISO standards.
Thanks, Aidan. The points you mentioned are really, really helpful, of course, for the industry. And as you said, and I think we discussed about ESG last year in the podcast. It's still a theme, of course, and there's all the energy related issue to it. And considering how you've been helping the industry in this, do you have to share with us real life example of a company adopting maybe your platform? And if so, what kind of benefits, what the benefits have been?
Sure. Thinking about it, Telehouse is a great example. We did our initial deployment with Telehouse about 5 years ago now. We were able to help them move very, very quickly and achieve a 15% reduction in their cooling energy use. So immediate return on investment there. And then using that increased visibility, Telehouse have been able to successfully identify further savings and secure quantifiable carbon emission reductions across their entire Docklands estate. The optimization recommendations have resulted in significant further cooling energy savings. And working together, we've reduced about 2,900 tons of CO2 emissions annually across their Docklands campus. And that really has helped contribute directly to Telehouse's broader corporate sustainability goals. So it's a big win there for Telehouse. Telehouse has continued to optimize their cooling systems and ensure that they're always right sizing the cooling for their IT load. And that's helped ensure continued CO2 emission reductions. So they're currently using us to monitor across 5 buildings on their Docklands campus. And that's probably about 7,500 racks and 500 air conditioning units that are monitored. And we're just about to release with Telehouse their liquid cooling lab. So all these colo operators are now starting to tread into liquid cooling. And they've put together a very innovative liquid cooling lab where customers and potential customers can come and understand what the liquid cooling options are available to them at Telehouse. And we're supporting that fully with the software so their customers can visualize in EkkoSense Critical what the software is going to look like to help them optimize their liquid cooling solutions. Other examples I can think of, companies I can't name at this point, but we work with some quite advanced fintech clients. We've gone through a long AI journey with them, GPU loads, and we're now helping them move into their liquid cooling side of things. So air cooling cannot provide enough cooling for them now. So we're moving with them and helping them deploy their liquid cooling solutions. And Bulk, who I mentioned at the beginning, we presented with those at Data Center World this year. That's a complete liquid cooling scenario, obviously hybrid, but primarily driven by liquid cooling. And that really is AI factory hyperscale type deployments. So we're seeing the use of EkkoSoft Critical across the entire range of liquid cooling options, and helping those clients optimize at every stage of their journey.
Yes, and you've been helping them to move from air cooling only and liquid cooling. So you can confirm from your experience that this is happening right now, especially in the last couple of years, the
Oh, it,
transition.
it's just accelerating. That's what we see at the moment. And you've
Yeah.
got other organizations such as Start Campus in Portugal. That's another publicly discussed sort of 1 gigawatt site. That's their goal. So we're getting some very, very large AI factories deployed in the European region, um, which are deployed geographically to maximize on either the cooling or the energy provision in those spaces.
That's quite interesting, and that's always helpful for our listeners and from us working, researching on this topic to understand how the industry is adopting and how it is transitioning to and using various emerging technologies. Now, I would like to step back and look more at the big picture of the data center industry. We talk about monitoring hybrid cooling systems specifically that use both air and liquid cooling isn't just a nice to have. You emphasizes how this is vital, especially with the increased adoption of artificial intelligence. And the innovations and instruments, sensor networks, analytics, all these technologies will determine whether the systems risk failure or not. And I wanted to ask you, again, from a general perspective, looking at the big picture, what infrastructure and instrumentation innovations are needed to actually monitor hybrid cooling systems at hyperscale, especially because we're mainly talking about hyperscaler these days. So yeah.
Yeah, I think that's where a lot of the AI factors are dropping into. It's entirely normal for data center operators to have these concerns where they're investing significant sums of money in risky areas such as liquid cooling, which is relatively new technology, particularly when they're bringing concerns that they don't yet fully understand and is very much part of the learning curve they're going through at the moment. The transition to hybrid air and liquid cooling to support AI compute needs very careful design, planning, and deployment, and then ongoing management when that's in production. Placing new AI workloads demands very smart capacity management and careful consideration of both space, power, and then the air and liquid cooling requirements as well. So this increases the need for real-time white and grey space visibility at the same time. And that's where EkkoSense can make the difference. The EkkoSoft Critical software is the only AI-powered data center optimization platform that allows operations teams to manage their real-time environment performance of their both liquid-cooled and air-cooled, essentially hybrid-cooled environments. With liquid cooling deployments, there's always an element of air cooling that sits alongside, typically 15 to 30% in the installations that we're working on at the moment. And that depends on the configuration of the racks and the CDUs that are installed to provide the liquid side of the cooling. There's a huge potential for optimization of this balance between liquid and air cooling. Because the AI workload, heat loads are so immense, you could actually end up using more air cooling than you've been using prior to liquid cooling. So there's still quite a significant demand for airside optimization as well. Without effective instrumentation, you'll never know if you had a problem. And that's more worrying than finding the problem. So successful liquid cooling deployments are all about understanding the potential risks, and having the right level of visibility into these increasingly complex cooling installations. When you're investing hundreds of millions in AI data centers, lack of visibility is just simply too big a risk for most operators.
I totally agree. As you said, without the instrumentation for monitoring, you will never know if you have a problem or not. I totally agree. And you mentioned before that big tech is investing unprecedented amount of money in data centers, which includes investing in liquid cooling. And you said it's relatively a recent technology. And I've been researching and looking other companies, and of course, there are many types of liquid cooling within the umbrella term liquid cooling, like immersion cooling, direct to chip cooling. I think you mentioned another couple before. Alongside these emerging technologies, we'd also be increasingly hearing about underwater data centers or even orbital data centers. So um, I hear you laughing. And so I'm very curious now to ask you, how do you see the future playing out, given the rapidly growing rack power, energy demands of the AI infrastructure we've been discussing so far? So do you see this, let me call breakthrough, even if like in some cases, for example, data center in the ocean, we had some pilot project, if I remember well, from Microsoft back
Hmm.
in 2015. But recently we've been hearing about SpaceX talking, envisaging a constellation of 1 million orbital data center in the low Earth orbit. So do you think this breakthrough will redefine how we build and cool data centers over the next decade, or maybe farther down in time? Or what do you think? That's my question.
It's interesting, isn't it? This is me going on record as to what I think, and then in 2 years' time, I'll be proven wrong. But we're seeing some really amazing shifts in this space, in the whole sector, not just in data center cooling. And you've got vendors that are bringing multi-gigawatt developments into place. In Europe alone, I know of two sort of 1 gigawatt campuses, and that's Bulk and Start Campus I mentioned earlier, that are already in production. And already in Q1 this year, we've seen in excess of $300 billion of capital commitments across North America, Europe, Asia Pac, and the Middle East. So really that global commitment. For me, I think the underwater and the in space, very, very difficult to service those type of installations. That's the bit where you'll come back in a couple of years and go, told you so on that one. I think what I see is data centers being put in positions, and if you look at bulk, they're purely hydroelectric power. So they're fully renewable on all their power, sat up in Norway. That's ideal. Um, and then you look at Start Campus, who are running a seawater cooling system down in Portugal. So you're seeing data centers geographically located where there is both land and there's, I guess, unique cooling or unique power provisions. Obviously, up in Norway, you've got a lot of free cooling going on anyway because of the climate. So it's much easier to service data centers. It's much easier to get that compute into that place. And also, I think something we need to consider as well is the drive and demand of AI compute and the GPUs that sit behind it. That technology is changing rapidly. So to pop something up in space or underwater, it's very, very difficult to change that technology and update it. It'll become outdated very, very quickly. So I still think we're going to be looking at data centers that are geographically located for the right reasons, on the Earth rather than underwater or out in space. But let's chat about that in a couple of years when Mr. Musk has put them all up into space. Um, I think successful data center deployments are all about understanding the risk and having the right levels of visibility into what's going on within that space. And when you're investing hundreds of millions in AI data centers, that lack of visibility is simply too big a risk for most operators. I think that goes back to whether it's in space or underwater. It's very, very difficult to do anything with it um, when it's in that condition. At the moment, EkkoSense is actually the only company that have got this extensive monitoring wrap around both liquid and air cooling operations to give you that full hybrid solution. And we'll keep evolving to make sure that we're supporting the data center industry as it introduces new cooling, power, and capacity dynamics. So we're always aiming to stay ahead of the current deployed curve. Given the costs involved with AI, it's infinitely better to identify and resolve those potential issues before they start impacting availability and the capability of the applications running on those platforms.
Thanks, Aidan. It's always very helpful to hear some insights from the industry. So we will discuss this in a couple of years. And it's been a real pleasure to have you again on Instant Insight. You can find a link to the EkkoSense website and to global data reports on data center in the episode description. Thanks all for listening, and from us in Strategic Intelligence, see you next time.